you're all there. Wonderful. Hello. Cool. I'm excited too. I'm so happy. Yeah, this is great, you guys. Okay, we're gonna live stream some yoga, and then we're gonna learn how to use Git from the bash, right? So let me switch over into Yoga Studio mode here. Awesome. I'm just going to change my camera a little bit. There we go. That looks good. Okay, everybody, let's begin by allowing your head to fall to the left and fall to the right. Oh, very good. And now look all the way to the left, look all the way to the right. And then rotating the head all the way to the front. Change direction, go the opposite direction. Cool. So, take your two hands, bring them together, rotate your wrists. Change direction, go in the opposite direction. Cool. Take your two hands, put them just below your shoulder blades. And this time try to bring the two elbows into touch and then pushing all the way back. Feeling good stretch now, opening up the neck and the back and your chest opening up as well. So change direction. Wonderful. Take your left arm, stretch it all the way out. Grab the fingers of your left hand, bend them backwards so you feel a nice stretch now on the back of your left arm. Turn around the other way, rotating in the opposite direction. So now the left arm is bending the right arm back so you can feel a stretch along the back of the right arm. Change direction, give your fingers a little bit of a wiggle. Cool. Alright, moving down the body, stepping to the left, bringing the right arm up, reaching up towards the sky. Give your fingers a little bit of a wiggle. And then reach all the way over. So, let's try the other side. Stepping out a little bit to the right, bringing the hand up into the air, reaching up towards the sky, and then look up towards your fingers. Reaching across, feeling a stretch now on the left side of your body. And then coming back up to stand again. So now, take your hand, place it at the base, take your left hand at the base of the left spine, right hand just below the navel, and just rotate your hips. And then change direction. Now take your two hands, put them on your knees, and rotate your knees. Coming back up to a standing position. Stand on your left leg, stretch your right leg out, and rotate your right ankle. And then change direction, go in the opposite direction. Standing on the right leg now, stretch your left leg out, rotate your left ankle. And then change direction. And then give your body a little shake out. We'll just do a few little poses today, not too many, right? We'll try the forward bend and maybe we'll try one or two, just for the shoulders, yeah? Maybe I'll change the mat this way and do it sideways so you guys can see a bit better. Excellent. Everything looks good there. So to begin, standing with, just feeling relaxed. 2 hands, deep breath in, reaching backwards. Exhale. 2 hands falling down towards your feet. Relaxing the shoulders. Very good. With every breath, you can come down a little bit lower in this stretch. And then if you feel it, grab the back of your legs, bring your head in towards your knees. Fold your arms. Allow your shoulders to just be completely relaxed. And then come down to the ground, walk your hands out, stretch your 2 legs, stretch your legs out to the side. Stay in this position for a few seconds. And walk your hands out, drop your knees to the ground. Bring your ankles back together and rock your hips back and forth. Wonderful. Okay, try bringing your bum up into the air now. And you're into the pose called the downward dog. You walk the hands forward a little bit. Drop your knees to the ground, and you're into the cobra. And then into the child's pose. Cool. Alright everybody, that's a little bit of yoga, just some poses. Why don't we try 3 rounds of Wim Hof breathing, and then we'll get in and learn all about git. Cool. So, find a comfortable place to sit. If you're sitting at your desk, this will also work. And we're going to do 30 inhales, exhales, and on the last one, we'll exhale completely. And as Wim Hof says, let the body do what the body does. Just feel that lovely feeling of all of the oxygen, like flowing through your body and into your mind, and just clearing everything up and giving you a lovely lift, right? 30 inhales and exhales. awesome. Let's try a second round. Wow. Ooh. Let's try one more. Oh, open your eyes, come back into the room. Wow, that was great. Namaste. Woo, I feel amazing. Wow. So great. I hope you're all doing those with me, because I'll tell you what, it really makes a difference. Okay, guys. Let me switch over into the screen thing here so we can do some things with Git. Okay. Right, time to begin. How to learn about Git. Right. First of all, just to say, I am sure you have been in the situation where you have been working on something. Could be like a Word document, or it could be a project, and you just decide to do your own kind of manual version control. So maybe you have a little, project that you're working on. Let me create a folder on my computer to do all of this thing. Let me go onto my desktop. It's probably fine. Say you're working on some old project and you want to write, like, I'm going to create a folder here. I'm going to call this test git. Why not? So say you're working on some project on your computer and you decide to make some text files or Word documents or whatever. And you end up making a text file here, and it's called like report.txt. And then maybe you want to keep like a couple of different versions of it. Then you want to add some more things to your report file, and you want to store the old versions of it. So you might say report from Tuesday. You store that there, and then you got another one, maybe report from Wednesday, and then you got report, like, we'll say final. So you end up with like loads of different, versions. Yeah, it is recorded. All the YouTube streams are recorded, and I'll put this on the Git repo for the course after today. So anyway, you end up with lots of different versions on your computer of the same file with lots of different content in it. Everybody has done this. So this is such a common problem, and it's so common that people need this solution. The whole stream will be there. Yeah, this is particularly important in software development, right? So say for example you make a game and you release your game, and then you want to add like a whole load of, we'll say, DLC. So you have a new version of the game maybe that people want to pay for, and you're going to charge for the DLC. But you also want to maintain the other version of the game that people have paid for. So you need to basically store that version of the game like in a separate thing. You need to keep that, like all that version, so that you can go back to that old version of the thing. And then we'll say do a build, of that, so you can like edit that thing. It's so important in software that people are able to do that. You imagine Windows, right? Like there's so many different versions of Windows. Microsoft needs to be able to say what exactly was the version of Windows from last year or 5 years ago or 10 years ago, or what's Windows 2 or Windows 3 or whatever. Go back to the source code for those old versions, right? It's so important that in software development that loads of different solutions have been developed over the years to basically manage that situation where you need to keep lots of versions, and you need to basically go back to the way things were a week ago or 5 weeks ago or whatever. So before Git, there was lots of other solutions. There was one called SVN. There was another one called SourceSafe, which was one that Microsoft had. There's loads of them. In the gaming industry, they use a system called Perforce, which does the same thing. But anyway, sort of like in the last, we'll say 10 years or so, I'm not exactly sure when it started, but this whole thing of Git has more or less just like taken over the software industry, and pretty much everybody uses it now. Like everything from game developers to web developers to people writing operating systems, even Microsoft themselves use Git. Everybody uses Git. And it's a way of doing this thing, of keeping track of different versions of the same project, going back to an old version, and basically keeping all those like snapshots of how the project looked, we'll say at a previous version. And it's so, it's really cool. Again, you imagine that you're working on something, you want to add a new feature, but you don't know if you're going to keep it or not. Well, wouldn't it be great if you just take a separate version of the project, work on that feature for a little bit. If you don't like the feature, you can say, okay, well, just scrap it and go back to the way things were before you messed everything up by putting this new feature in. So that's a really cool feature that, all of these things actually do as well. So anyway, Git, like I say, is kind of taken over as being the tool that software developers use for, you know, managing these kind of version things. So when we're talking about Git and GitHub, there's actually two things. There's Git, basically, which is the technology for version control, and then there's GitHub itself. And GitHub itself is like the website that holds all of the different versions, and like different kind of, you get a repository on GitHub to store like a version of your project on GitHub that other people can get access to and see the source code to. So GitHub can keep like private projects that you just want your team to be able to access. But GitHub, a lot of the projects on GitHub are what are called open source projects that anyone can go up and they can get the source code to. So that's a little bit of a background introduction to Git and GitHub. I'm going to just like explain a few concepts for you guys, and in order to do that I'm going to do my whiteboard here, okay? So let me get my whiteboard here, because there's a few interesting concepts to do with Git before we even like start, you know, into like what are the commands you type, right? So first of all is the concept of what's called a branch. All right, so Git has this thing called branch. So what is a branch? A branch is basically a stream of these things called commits. Right, and these are called commits. Okay, so a commit, what is a commit? A commit is a snapshot of the state of all of the files, right? A commit is a snapshot, I'll just say. So it's exactly what the file system looked like when you made the commit, okay? And these commits like are kind of sequential. So I make a commit here and I make a load of changes, and then I make another commit here and I make a load of changes, and then I make another commit here and I make another load of changes here. And you know what you can do with Git as well is you can roll back. You can say, bring me back to this commit here, which was at the very start, or to this commit here. And you know, all of these commits basically live on a thing called a branch. Now something else you can do with Git is you can create new branches. So I can have a branch in Git. The kind of like default branch in Git used to be called master. But because of the whole need, is it not the Black Lives Matter thing, they basically don't call it master anymore because it can be offensive to some people. So now the kind of like the thing in Git, the default was called the main branch. Anyway, so you typically can make all your commits onto one branch called either master or main. And then you can decide, for example, okay, I want to have a different stream. So you can decide to branch off at one point here, and maybe you can have like something like, let's say, new feature. So you can go off onto the new feature branch and you can make a whole load of commits here, and you can see that this branch got created from this commit here, and you can go and create more commits onto this branch. And then when you're happy with all of the commits on that branch, you can do a thing like where you can basically take all of that new feature stuff and you can then merge it into the master branch. So I could actually come in here and I could merge this branch in, and what it will do is take all of the changes from these commits and try and combine them with all the changes from these commits, so you're back onto the master branch here, and this is called merging. So like when you see this kind of laid out like this, it's sort of like, oh yeah, that's kind of what you would do. So again, just to explain the concepts behind Git, first of all, you have this thing called a branch. On the branch, you're making lots of commits, which are basically snapshots of the state of everything. You can create new branches off the branch, so you can basically create a new feature and you can create new commits onto that, and then you can merge your branch back into the master branch again. So anything else I need to say about Git before we begin? When you take all of your stuff like this in Git, all of this stuff here goes into, on Git, what's called a repository. Okay, so that's another important Git concept, where all your stuff goes into a repository. The repository contains everything. The repository contains all the branches and contains all the commits that were made onto every branch. So they're kind of like the main, you know, concepts behind Git. I maybe just throw a couple of other little things here as well. Lots of times, this is really important. I'm going to explore this a little bit more when we do some Git stuff here. Is this concept of the git ignore. So Git is for source code and image files and WAV files and scene files and stuff. It is for all the stuff required to build your project. It is not for things like exe files and all of the stuff that Unity makes when you're actually making a build. All of this stuff doesn't go into Git because it'll only just mess up your Git repository and you'll end up getting what are called merge conflicts. So in the root of your Git repository is one file called .gitignore. And in this file is a list of all the files that you want Git to leave out of the Git repository. So So I'll show you in this class, I'll show you what a git ignore looks like for processing, and I'll show you what a git ignore looks like for Unity as well. Because they're the two types of git ignores. It's kind of important that you know about this file as well. And then there we are in Git. Right. So there's lots of ways you can access a Git repository and make Git repositories. You can use the GitHub client. You can use a thing called Git Kraken. There's loads of Git clients. But in this little example here, I'm going to show you how to do some Git stuff using the bash. The bash is where you type commands into what's called a terminal window. And this is typically how programmers use Git. I have used the Git clients, but to be honest with you, maybe just because I learned this way, I actually find the Git clients more confusing than just knowing exactly what's happening in Git and what commands do and stuff like that. So, and there's actually not that many commands you need to learn either. Maybe like maximum, 10 or 15 commands, and then that's it. You're a Git boss. You know as much about Git as I do. All right. So, cool. So when you install Git, you can install Git, like you can get the Git Kraken, but this is what I usually install, Git for Windows. And when you download Git for Windows, this is typically what you get. You download this thing here, and this gives you like the basic commands that the terminal and the basic sort of like commands for the Git program. I don't use the GitHub client or anything like that. I use this thing instead, right? For the Mac, it's like you can just do Google Git for the Mac and then similar thing. And when you install Git like this, one of the programs that it installs is this thing called the bash, right? So when you install the bash and you click through all of that stuff, you now have the capability in Windows to right click on any folder and choose Git bash here. And it will launch this thing called the bash for you, right? So what is the bash? Bash stands for Born Again Shell, and it's like an alternative way of interacting with your computer than using dragging windows and stuff like that around. So you can do everything that you can do from like the Explorer in Windows. You can do from the bash by typing bash commands, right? So bash concepts. Maybe if I was doing this over a longer period, what I do is I'd separate this into smaller videos. But this is the first so now we've done like Git concepts, like what Git is all about and what's the difference between Git and GitHub. And now I'm going to the next part of this would be, what does the bash do? The bash is this place where you type commands into, all right? It's not like a Word document or anything like that. The commands don't as such get saved into anything. They're just like, I type a command and it does it. So here are some bash commands that you might want to know. The other thing I have is a really, really great lab all about this, which I will put onto the Git repo for the course, and you guys can try all of this yourself. But again, if you want to try this, you know what, you guys can type along with me today as well if you want to try it. The first thing to do is to go and download the Git for Windows thing here, or the Git for Mac. If you download Git for Mac, then you just start the terminal on the Mac, and all of this stuff will work. Right, the bash. This is the bash. So we type our commands into here. We type our Git commands. We type lots of other commands. The first important concept about the bash is what's called the current working directory. Current working directory is like where all of these commands that we type in are going to run. So it actually says here, ~desktop/test-git, right? So this is basically saying from the desktop there's a folder called test-git, and that's the current working directory. To get the current working directory, here's our first bash command. You type pwd. Hey, here's a good tip for you guys. If you're following along here and you want to remember all of this stuff, what I suggest you do is take out a notepad and write these down in a notepad, like either pen and paper, or open up like Google Keep or something on your computer so you can record these things. And just write down these commands, and beside them write down what they do. And this is how I learned Git as well. I basically created it says no data. I wonder what does that mean. Okay, cool, working again. It just created a little text file on my computer, and I wrote down the command, and then I wrote down what the command did. So pwd means print working directory. And that's the first thing. So the next command on the bash that you might want to know is cd. And cd stands for change directory. Alright, so if you want to go one level back up, you type cd space ... and press enter. And you see now that it's changed the command line, or it has changed the, if you do pwd, it has changed it to C users Brian desktop, whereas previously we were C users Brian desktop test git. So that's what cd space ... means. ... means go back one level. Next command is ls. So when you type ls and press enter, it shows you a listing of all of the files in that particular folder. So ls basically is like, yeah, showing you the files in a folder. So we want to cd back into the, I want to cd into the test git folder. So watch what I do here. I type cd, which stands for change directory, and then you pass in the name of the directory you want to go into. So I'm going to type in t, e, and then watch what I do. I use magic finger. I press tab, and tab does completion in the bash, right? So it brings you into test git / like that. So there I'm in the test git folder now. So what have we learned? We've learned pwd, print working directory, cd ... which goes back one level, and then cd, the name of a folder, brings you into a folder. There's lots of other stuff you can type. mkdir makes a directory. cp for copying a file. So there's loads of different commands from the bash, but like there you go, for navigating folders you've got cd, and you have cd ... and you've got pwd. So my working directory is the test git folder. Alright, now I'm going to say this now. I know it's going to take like 10-15 seconds for you guys to hear this, but I am about to type the first git bash command. Who is excited to see the first git bash command? And I know I'm going to wait 10 seconds before I see this, but I'm going to assume you're all excited, right? Here's the first actual bash command. It's git. Are you ready for this one? Init. So you type git space init. In the folder you want git to manage, and you press enter. Oh my goodness. That's it. That's the first git command. Still nobody says they're excited. I'm presuming it's just because of the delay in the stream. I presume you're all like excited. Hooray! Yay, that's better. Okay, git init is the first one. And you type git init in the folder you want git to manage. Alright? And so now desktop test git, and now look what's happened. The git bash has brackets master. Wow, okay. So that means we're on the master branch already when you type git init. Look what actually happens to the folder when you type git init. Now to do this on Windows, I'm going to go view, and I'm going to uncheck hidden items here, right? See, it's now checked. And you see there's now a folder in here called .git. This is the folder where all the git stuff is stored. All the old versions, all the branches, everything is stored in this hidden folder called .git, which you can only see if you check this hidden items thing here. You shouldn't really ever mess with that folder, but just to let you know, if you delete that folder, that is deleting the system, or sorry, it's deleting the history and everything git related. It doesn't delete any of the files which are like in the folder, but any of the branching and all that stuff is all gone. When you delete that folder, you're deleting git basically from that folder. Like again, if I was to do pwd or just like ls, you'll see the master thing is gone now because there's no branches anymore because I deleted the .git folder. So we'll go back and type git init again. So git init now has initialized git, and we're doing git in that folder. Cool. I'm going to make a processing sketch in this folder. Why not? I'll use this for doing processing. So I'm going to delete these old 3 files here, delete them all, and I'm going to create a new text document here, you know, and I'm just going to call this test git because I'm going to make this for processing. .pde, which is the file extension for a processing sketch, right? So now it becomes a processing sketch, and I can jump into test git and I can edit the file. Now before we send anything to GitHub, I'm just going to show you some of the git commands you can do basically to do commits and to add files and stuff like that. So here is the test git in processing. This processing on this computer is weird. It takes a little while before you can type. I don't know why. But then suddenly you can start typing. This computer does loads of weird things every day. It's a real Frankenstein's monster. of like USB things plugged in. Hey, we can type. Void setup. Cool, there we go. Let's go in here and let's go background. No, it doesn't even matter. Let's just go this. Text size 24. Let's go text align. Center. Let's go text width divided by 2. Height divided by 2. Oh, get the order of the parameters right, and let's print the text. Hello, Git, like this. Cool. Let's just make sure it works. Oh, that one, comma. Saving my sketch, hitting the play button. Fantastic. Look at that, everybody. Hello, Git. Okay, nothing too exciting there. I'm going to click stop on my sketch here, and I'm going to go over to the bash, and now I'm going to make a commit from this change that I just made. So let's go back over to the bash here. I'm on the master branch. It says master already. How do I actually make a commit out of that, right? This is how you do it. You do it in 2 steps. The first step is to take all of the files in the file system and copy them to a special area called the staging area. So the staging area is like a temporary area before the commit is actually made. So the files get copied from the file system to the staging area. Then when you do the commit, they get committed into the branch. So step 1, git add dot. And it's git space add space dot, and you press enter. And that takes all the files, adds them to the staging area. Now we are going to make a commit onto the master branch. And to make a commit using the bash, you type git commit. Very important, you do -m. -m stands for message. And then double quotes, you type a message. So you're just going to type hello git. That is a message. And that message string gets associated with the commit. So you can see later, oh yeah, that's that change. That's whatever change I made at that time. So then you press enter. So now I have made a commit. And it says master root committed, hello git, 1 file changed, 11 insertions, create mode, test git.pde. So now I have made a commit, all right? Next git command, git init, git add dot, git commit -m has made the commit. Let's make another commit, right? I'm going to make another commit here, and I am going to show you how you can switch between the different versions of the project then. So there's the text. Let me change that text from hello git to be hello Brian. Alrighty, so I'm going to save that file there. I'm going to come over here and now make a second commit with that change that I just made there. So you're going to do git add dot, and then git space commit space -m. And then we're just going to type a message. So this is going to type Brian. Doesn't really matter. It's just a string, and then press enter. So now I've made 2 commits. Fabulous. We've created an empty Git repository. We've started making commits on that Git repository. We've set this folder up to be managed by Git. And, you know, this isn't too hard using the bash so far. So there's my 2 commits made onto that branch. If you want to get the history of a branch and see all the commits that have been made to the branch, you type git space log and press enter, and then it will show you the history of the branch, right? So now it's saying, look, here's commit first one with the most recent one, and it's the commit with the string Brian, and here's the commit that we made previously, and it's got the string hello git associated with it. Now imagine that I wanted to go back to the version of the project where it said hello git. So you can see that there's a log of all the commits on this stream, on this master branch. There's this commit and there's this commit. And each commit has this big long string of characters associated with it. This is actually 40 digits. This is a 40-digit hexadecimal number, being a base 16 number. Did we do base 16? I know we did binary numbers. We did base 16, so this is the hexadecimal number that is associated with that commit, right? So if I want to go back to this version of the project here, what you do from the bash is you double click on that 40-digit number, which copies it to the clipboard, and you type git checkout, and then you paste in that 40-digit ID. So you go paste in like that, and what will happen now is the thing kind of gets rolled back. Everything gets rolled back to the way it was. So if I jump over here again, you see that has changed now to hello git. So it's undone that little edit thing that I made there, and it's gone back to hello git. Again, how you do that is you get the log, you get the 40-digit ID of the commit, and then you type git space checkout, you paste in that 40-digit ID, and it will bring you back to the version of the project at that point. How I get back to the head again, the head thingy is you type git checkout master, and it brings you back to the head of the master branch. M-A-S-T-E-R brings you back to the head of the master branch. Jump back over to here, and now it says hello Brian. Cool. So we've made commits, and we've been able to roll back to a previous version of the commit. Again, if you have your little text file open up there, you should be writing down git add dot, git commit minus m, git log, and then git checkout, and with the 40-digit ID, and you can roll back to all the versions. Okay, now it's time to connect this Git repository up with a repository on GitHub and synchronize them. One of the things about Git is called a distributed version control system. So with other version control systems before Git, they were client server. So there was a server that held the master version of the project, and then you had a client, and you had to basically talk to the server whenever you wanted to get the latest changes. With Git, it's called a distributed one. It's called distributed because the repository on my computer is the same as the repository on GitHub, and if like you had other people cloning the repository, cloning is an important concept, there's no master version. There's no master version. They were all equal in the Git world. That's why it's called distributed, right? So anyway, let's see how to connect this up with a Git repository on GitHub, right? So first thing you do is go up onto the GitHub thing, and you create a new repository up here. So you click this button here for new repository, and you give your repository a name. Now you can call your repository anything, but because later if I want to get this repository from the server, it's going to use this name, for me it makes sense to use the same name as the sketch, because the folder is called test git, right? So I'm going to select test git there, jump over to here, and put in test git here. Oh, it already exists on this account. Let's go and delete the test git repository. Excuse me, because I've already done this. I'm going to delete the test git repository because it's already there from a previous class. Let's find test git. Oh, test git. Here's test git. Processing already. I'm going to delete the repository 5 years ago. Settings. Delete this repository. I'm going to delete the old test git one so I can make another one called test git. Confirm password. I'm supposed to do this, aren't I, when I do a password for some reason? I don't know. Let me stop the stream for a second. Again! Hooray! Okay, that was me typing my password. Anyway, here we go. Oh yeah, your repository was successfully deleted, right? So I'm back up here to GitHub thingy again. Test git, hooray, we can create it now, okay? So that's the name of the repository, and then there's a few other fields we can fill out here in the Git thingy. First is the description, and we're going to put a description in here. I'm going to put this in a test git repository. A test Git repository is fine. What happens with this description field is in every Git repository there's a readme file. It's called readme.md, and whatever you type into the description field here gets saved into that readme.md file. So this is called a test Git repository. You can make it public, which means anyone can get access to the repository, or you can make it private, which means you can just invite people to be able to make contributions on the repository and see the code. Yummy. So we'll make it public, right? It says, do you want to add a readme file? Let's choose yes. This is like the file that this text is going to get saved into. Do you want to add a gitignore file? Yes, you always want to add a gitignore file. Always. And this is so important. This gitignore file and how it's set up and what's in it is really important, particularly for Unity projects. And if we don't get time today, I will show you how to do this whole thing for a Unity project and why you might want to edit the gitignore file that GitHub gives you. So we want to add a gitignore file, and it asks you, do you want a template for your gitignore file? Let's choose processing. There's processing. Choose a license. I always use the MIT license because it's a permissive license. Basically says anyone can use the code if they find it. This will set main as the default branch. I'm going to change the default branch to be master. GitHub made this weird change, like I say. I'm going to change it to be master. Update. Cool. Okay. GitHub made this change where they changed the default branch name from master to main. I guess it makes sense, but it sort of screws a lot of Git stuff up. And you have to sort of work around it. So I just changed it back to master, okay? So anyway, create repository. Wonderful. So now there's the repository. Oh, where is the files? I thought I chose... Hang on a second. Where's add a readme file, add a gitignore, choose a license. Oh, I choose all those things. So where is my repository? Test Git. Okay, cool. That's better. It was weird. Okay, so here's the files that GitHub has created. It has created the gitignore file, it's created the license file, and the readme.md file. So these files are already in the Git repository, just from that form that I filled out on the previous screen. If you look inside the gitignore file here, this is a listing of all of the file types that Git is going to leave out of the Git repo. So it's going to leave any applets out, any of these folders will get not included in Git. You know, when we make a Unity one, you'll see there's a whole load of like things that Unity puts into your project folder. And again, you don't want those to go into your Git repo. So it's really important that you have that checked, that box checked with the gitignore file, right? And here's the license, so you can read the license, that's the MIT license. And then here's the readme.md file that GitHub has created. If you look at the raw version of this file, this is exactly what's contained in the file. So it's hash space test git, a test git repository. So it uses a format called Markdown. And this is a really simple format, you know, where you put a hash in and it makes it a heading, and you put like a minus sign and it makes it a bulleted list, and there's a little format for images and stuff. And you guys will notice that this is exactly how I write, you know, your labs every week. I write them all in Markdown format and store them in the README file. So that's basically how all that stuff, you know, it gets formatted and it looks so nice. So it's gitignore, license, and README files already created, and we have this repository up on the GitHub server. Now, another exciting moment is about to happen, because now we are going to make the connection between the local Git repository and the Git repository on the server. We're going to connect the two of them up together. So who's excited to see how this works? More Git commands. Watch what I do here, everybody. In my browser, I am going to select this URL, the GitHub Scooter 500 test git, because this is the URL for my repository. And I'm going to copy it, Control-C, copy it. Over here in the bash, this is the command that you type to connect this repository with the repository on GitHub. You type the following: git remote. So the first thing is, Git has this concept of remotes, and you can set up lots of different remotes. but a remote is another Git repository that you're going to want this repository to be linked up with. Git remote, and then the next byte you type is add, because you want to add a remote. The remote we want to add by default ORIGIN. Okay, so the remote can be called anything, but there's a couple of remote names that are used by default. The first one is origin. Lots of Git commands, when you type them, you can type in a remote, and if you don't type in a remote, it uses origin as the default. So this is like the origin repository that you want to communicate with, and the default one, and it's called origin. So git remote add origin, and then you paste in the URL. Now this URL this origin here becomes an alias for this URL, right? So origin now is this thing. That's what origin is. You go git remote add, gonna add a remote. Origin is the default one, and then you're saying the default one is this URL here, and you press enter. Oh my God, we've now connected up these two repositories. Fabulous. Okay. Now, the next thing we're going to do is we're going to send the changes from this computer to the GitHub. Now, before we do that, I want to get the GitHub gitignore file, and I want to get the readme file from the GitHub server, and I want to bring it into this repository here, because I want the gitignore file to be set up before I go and send stuff to the GitHub server. Anyway, how we would do that is we would type git space pull, and git pull basically will communicate with the remote server, pull any changes from the remote server into this folder. So git pull, press enter. Okay, cool. So it's giving us an error saying there's no tracking information for the current branch. Please specify the branch you want to merge with. The very first time you type git pull or git push, you have to type git. You have to connect this branch with the master branch on the server. Such a pain. Git branch. We could have done this in a slightly different way, or in a different order, and it would work fine. -- set upstream to origin master. Let's try that. Whoa. Branch master set up to track remote branch master from origin. Okay, this looks good. So now I've connected this branch up with the branch on the server. Now I can do git pull. Yay! The git pull worked. So we've retrieved those files from the server, and they're now in my local computer, right? Because I connected up the two branches. You see this git branch thingy here? You don't always have to type that. Sometimes when you do git pull or git push, there's a way of adding a flag there that you can basically connect the branches up as well. This one works fine, okay. But if you get that error, that's one way to fix it. So anyway, looking back at the folder here, right? Here's my test git folder. Now look what I have. I have gitignore, I have readme, and I have the license file. So these are now coming from the server, and they're on my local file system. So now let's send our changes to the server, right? Now maybe do we need to do a git? No, I don't think we do. Well, I think if I just do git push, it will send my changes to the server and all of those commits. Let's just try it. Git push, press enter. Fabulous. So git push is the thing that takes all your files from the local file system, sends them to the server. So now if I hit refresh over here, I have my test git file, I have my readme file, I have my license file, my gitignore file. So I have all of the different files, that I've been working on. And look what it says, there's 4 commits. So where are my 4 commits coming from? Let's click on the 4 commits. And this is a cool thing you can do with the GitHub website. It shows you the diffs between all the commits. Look at this. So this was the merge, right? This was the pull. This was the initial commit. This is the one then committed 7 minutes ago, 2 minutes ago, 7 minutes ago. And then this is the Brian commit, and then this is the hello git, which was the very, very first one. Look what you can do here. You can click on this little ID thing here, and it brings you into that, and it basically says, hey, look, it says between this, commit and the next commit, look what change you've made. First of all, it said hello git, and then you changed it to hello Brian. So it shows you the actual lines of code that are modified between the different commits. So if I come back over here, and maybe I'm just going to add another like few lines, I'll add a method, right? So if I do, and then I add another method there, and then I'm going to do one more commit here. I'll show you the kind of sequence that we're going to do. We're going to do git add dot, git commit space minus m hello. So like if you're using the bash, you're going to be doing this git add dot, git commit, git push over and over and over again. Git push. So I got another commit sent to the server. I'm going to click refresh here, and now I have this hello thing here, and here we go. So you can see then I've added this little string, this little bit of hello to the end of this thing here. Now, let's see, what should we do? So we've done gits, we've done commits, we've done the initial setup and stuff like that. I suppose the next thing I can show you guys is how to do branching, because branching is pretty simple as well. By the way, there's one thing I would highly recommend everybody does, and that's to read the Git manual. Alright, you only need to read the first 3 chapters of it, but it basically goes through all of these Git commands, branching, the concepts, everything. Just read the first 3 chapters, and I highly recommend everybody does that. Like, no matter if you're learning this from a video or whatever, like, it's well worth reading that. It'll take you just like an hour to read the first 3 chapters, and you'll have all the stuff that you ever need to do in Git is in that manual. Okay, branching. So this is how branching works, right? I'm on the master branch now. I'm making all my commits on the master branch, and I can roll back to an old version from the master branch. One of the things I might want to do is like go off and do a different version of my project, delete all the files, you know, add loads of stuff. Let's create a branch, right? To create a branch, you type git checkout space -b. And then the -b, when you put the -b when you're creating your branch, this is another one to go into your little text file. When you're doing the -b, this means create a new branch. So -b, and let's call this new feature. So I'm going to press enter, and I'm on the new feature branch. And you notice now that it has changed this bash thing to say new feature. Instead of saying master, it says new feature, because I'm on the new feature branch now, right? So in the new feature branch, I'm going to put some code. Let me put something that just does print ln hello, and let's also maybe add a new tab here, and I'm going to call this tab hello. Why not? So now there's a hello.pde, and I'm just going to put some text into hello.pde. Hello. And save everything. So there's my sketch saved. So I've got a new file, and I've got some new lines in the file. And I have made these changes on this new branch. So I'm on the feature branch, this new feature branch. So let's make a commit onto that branch. Git add dot, git commit. And then I can push that by going git push. Oh, watch what happens when you do git push, right? The very first time you push or pull from a stream, you're going to get that same error that I got before. And it's saying, hey, you got a new feature branch here, but there's no new feature branch on the server. You got to link them up together. So when I do git push, it's going to say, hey, look, what's the error says here? Look. Fatal. The current branch new feature has no upstream branch. So there's no new feature branch on the server, but there's a new feature branch here. So you can type this thing instead. You can type git push, and only the first time you have to do this. Git push -- set upstream origin. Watch what I'm doing with my key, my magic finger. Tab new _ tab. So that will do the push, and it will connect the 2 branches up together. You can do that previous command, which is git branch, and it will create the branches and connect them that way. This is kind of a cool way to do it. So now when you go up to the GitHub thing, the test git repository, it says, look, new feature has recent pushes less than a minute ago. So here's master, and here's new feature. You can switch between the new branches here, and it shows you like the branches in the GitHub client. It shows you the different branches that are created, and you can switch between them. Yep, so you got master and you have new feature. Now, how you do this from the bash, how you switch the branches from the bash is here I am on the new feature branch. If I want to switch back to the master branch, so git checkout is like used to do a few things. You can roll back to a previous version using git checkout. If you do git checkout -b, it will create a new branch. If you just type git checkout master, this switches from feature branch to master branch. Git checkout master, press enter. Now when I come over here into the git thingy, remove permanently, here we go, test git is gone, and that file is gone as well, because it's not on this branch, right? There's a file and it's actually gone. The file is actually gone, right? Because it's on a different branch. Switching back to that branch I just created, I can do git checkout new feature. NE, pressing tab for code completion and pressing enter switches to the new feature branch, and there we go. The file appears again. There's hello.pde. Coming over here, there's hello.pde. Switching back magically again to the master branch, git checkout master. Switching back to the master branch, there we go, the file is gone. Is that cool for everybody? So you can switch branches by using git checkout as well. So say I've gone over onto that new feature branch, and I've gone and implemented some new thing, and now I want to say, okay, bring that change into the master branch. How you do that is another git command, and it is basically git merge. So git merge takes the changes from another branch and merges them into the current branch. So git merge new underscore feature. And now it'll take the changes, merge them into the master branch. There we go. And then I can do git push, which sends those changes to the server. I'm going to show you one last thing, because you know what, guys? That's nearly everything you need to know about Git. Like in less than an hour. That's basically how to create a Git repository from the bash, how to make commits onto your Git repository, how to create the Git repository on the server, how to link the one on the server with the one on your local computer, and then how to send your changes from the server to the local computer by doing git pull, and then how to send your changes from the local computer to the server by doing git push. It's like there's not that much to it. There's not that much to it. And if you were to write all of this down, and if you're keeping all of this in your little notepad, you'll just see, what have we learned? We learned about 10 commands so far. We'll list them before we finish. The last thing I wanted to show you guys, because like that's 99% of it, is how to deal with something which is definitely going to happen to you guys. And the first time it happens, you'll go, ah! You'll go, because it will be very frightening. A unity git ignore. I might do that in a different class. But I want to, well, if we have time, you know what, I'll do it later on today in the afternoon. I'll show you the unity git ignore. Yeah, good point. So we'll do the unity git ignore in the next class, because maybe I'll just show you this cool thing. It's called a merge conflict. Okay, I'm going to show you how to deal with a merge conflict. Merge conflicts will inevitably happen when you have multiple people working on the file. One of the things normally about Git is Git really doesn't matter. Like it allows multiple people to work on the same file at the same time. But if two people edit the same bit of the same file at the same time, then you'll get what's called a merge conflict, and you'll get a merge. Let me show you how that's going to look, right? I'm on the master branch now. Say I'm on the master branch. And we'll say on the master branch, right? Am I on the master branch, right? I'm going to add a, let's go and add, I'll do two of these things. I'm going to add a PNG file, right? I just right click on here and go new bitmap image. Bitmap is fine. Bitmap will do the job, or PNG. There's new bitmap image. I'm going to call this test.bmp, right? There's test.bmp. Let me edit test.bmp there, so it's opening up in, doesn't appear to support this format. Alright, it didn't even make it properly, no problem. Maybe I need to run MS Paint. You know what I'm thinking? I will actually do it for a text file first of all because it's a little bit more straightforward, and you're gonna encounter these, and I'll show you afterwards if we have time. We might switch over to the project fair at 1:30 and like tune into those guys for a little while and see what the crack is. Anyway, I'll show you how it works with a text file. I'll show you in the second, like after the break, you know, I'll show you guys how to do it with a binary file, and then how you do all of the stuff for Unity as well, right? Okay, I'm on the master branch, right? On the master branch here. Where is my sketch? Right, here I am on my master branch here. Let's say I want to change this text on the master branch to be hello Star Trek. Hello Captain Beefheart. Okay, so there's hello Captain Beefheart, and I'm going to click save there, and down here I'm going to put in a piece of text. I may be hungry, but I sure ain't weird. Okay, so that's a line from a Captain Beefheart song, right? I'm going to save this. This is the master branch. All right, watch what happens here. Git check out new feature. Check out the new feature branch. Obviously those changes are going to be gone, so I switch over to here. Why is that file there? Okay, hang on, let's do this again. Sorry, let me go git check out master, because I haven't committed those changes onto the master branch. Then we do git add dot git commit -m, let's say captain. Okay, and now I'm going to switch on to the git checkout new feature branch. Okay, so on the new feature branch, that changes does not exist, right? That change is like on the new feature, on this branch here, it's like hello Brian, and here it says hello, right? You can see that. I'm going to git checkout master, switch back onto the master branch, and you can see the text has changed. Everybody got that? Alrighty, let's go and check out the Brian branch, or the new feature branch again. So I'm on the new feature branch, and I'm going to edit this exact same line of the same file. In fact, we can edit a few different bits. Let's over here just put in like maybe another method. There we go. So I've got another method going on there, right? And I have the hello, and this hello Brian I'm going to edit. I'm going to say this is going to be hello Star Trek. It doesn't really matter. Hello Star Trek, right? And then what do they say in Star Trek? They say to boldly go. Alright, so you can see I've edited this line, I've added this method here, and I've changed this text to be to boldly go, right? So let me commit this here. Git add dot git commit -m. So there we go. So I've committed that change onto that branch. If I go back to the master branch, okay, here's the changes on the master branch. Again, just to show you, hey, by the way, just to show you what I'm doing here, I'm pressing the up arrow, and the up arrow brings you back to your previous command. So that's doing git commit -m to Star Trek, right? Oh no, here we go. Let's go git checkout. There's the new feature branch. New feature branch has all of these changes on it. I'm going to check out the master branch again. Has these changes on it? Now, watch what happens. Oh yeah, that's right. The very Michael just says can't commit using git, need global name and email for it. That's no problem, Michael. The very first time you start typing these git commands, you have to set up your name and you have to set up your email address. And the GitHub, if you look at the error that comes up, it tells you exactly what to type to set that up, right? And that's because the commits get assigned, you know, your name and your email address gets like stored beside the commit, right? Okay, cool. So git checkout master, you can see I've got two branches. Okay, watch what I do here when I do the merge. When you do a merge, Git will try to merge the changes in those two files. But it's going to run into a problem because I've edited the same line in the same file. But watch what happens. Git merge new feature. Okay, a thing is going to happen now. Is everybody excited? The thing is going to happen. I'll just assume that you're all excited when the thing happens, and it's going to be like major. It's going to be major. And the first time this happens to you, you're going to go, ah, no. This is how you handle it, right? Watch what happens here. I'm going to press enter. Okay, it says here, auto merging test git, right? So it's trying to merge the changes from that branch in the file test git with the changes that are in this thing, and it says merge conflict, automatic merge failed, fix conflicts, then commit the results. Ah! Look what happens to the file. Oh my god, look. The file is all screwed up. This is what Git does when you have a merge conflict. It puts these little annotations in the file. So it says head, and then it puts this thing here, and then it says this is new feature, and then this is head, and this is new feature here. So it puts these weird looking annotations in the file. Now you can just go and manually edit all of this stuff out. It's saying basically, this is head. This is what's from the master branch. This is the bit you're trying to merge in. And it's saying like, which bit do you want to keep? Down as far as here. This is the end of the new feature bit. And then it's saying, this is in the master branch. This is the thing you're trying to merge in. What do you want to keep? Like I say, you can just edit this file manually. But much nicer is to open up the file in Visual Studio Code if you have Visual Studio Code on your computer. Look at this. If you open it up in Visual Studio Code will help you to resolve this merge conflict. So it's basically saying, right, which bit? Do you want to accept the incoming change? The incoming change is, do you want to accept the merge that's coming in? Or the current change means, do you want to accept the change from this branch, or do you want to accept the incoming change, or do you want to accept both changes, or do you want to compare them? Let's compare them. Look, it's saying here, choose compare them. It's saying hello Captain Beefheart, and this is hello Star Trek, and this is the thing here, and this is the thing here. So we're comparing the changes. That's what happens when you compare. You can choose to accept incoming change, and then it replaces it with hello Captain Beefheart. So it takes the one from the master. If you choose it, sorry, that's current change. If you accept incoming change, it takes the one from the branch. You can accept both changes, it leaves both things in there. Now down here as well, you have the option to accept current change, accept incoming change, accept both changes, or compare the changes. And here's the compare the changes. I may be hungry, but I'm sure where it gets replaced with to boldly go. So again, you can choose which one you want to accept. Let's accept the incoming change, right? So I get this thing here, and it's taken to boldly go from that other branch, and you can choose save. And when you get a merge conflict, that's all you do, right? That's a merge conflict in a text file. I want to show you how you deal with a merge conflict on a binary file because it's slightly different. We got 5 minutes before the stream starts for the project fair, so I think at 1:30 we'll switch over to the project fair for a little while and see some of the projects. And then after the break, when we come back, I'll show you how to do this with Unity. I'll give you guys a GitHub lab. If you haven't already, a good thing to do will be to take your assignment that you're working on and get it going on GitHub like this, so that you guys can collaborate with your code and you don't have to keep like multiple versions of your project and stuff like that. And you can deal with these merge conflicts now because you know they're no big deal. You know, you just open up the file in Visual Studio Code. You know what's happening. It's basically saying there's edits in two parts of the, you know, the file is being edited in the same place in two branches, and which one do you want me to merge? So yeah, binary file. Let's say here's my folder. Did you do git add dot Michael, git commit? Can't commit, use global. Excellent, you did that. Working tree clean. That means there's no changes to commit. Maybe there's no files. All right, last thing, right? Look at this. I'm going to click new. Oh, no, here. Let's do it in MS Paint. You know what? You can use things like the git kraken and all those other things, but you know what they're doing? They're basically just calling these git commands underneath. So if they don't work, you can just, as I would always say, fire up the bash and start typing. So here's an image here. Let me go to properties, set the sizes to be like 100 and 100. And I'm going to just draw something onto this image. Hello. Let me just do a big B. Here's a big B. And I'm going to save this file into the folder, the test-kit folder on my desktop. So there's image.png saved onto the folder there, okay? So in the git bash over here, I'm on the master branch. Okay, there's my merge thingy fixed. I'm going to do git add dot, git commit -m. Just to show you, by the way, if you don't do the -m, this is like one of those things where, you know, the universe explodes. And you're like, ah! If you don't do it, sometimes what it does is it starts up this program, which is actually called VI, or Vim, the editor. And you're like, how do I get out of here? What is it doing? I'm going to tell you the magic trick to get out if you forget to do the -m flag. This is a magic trick. Everybody ready? You press escape, you hold down shift, and you press ZZ. And what that does is it actually saves the file. You know, it's basically, you have to type a message, and like it starts an editor called Vim, and then, anyway, there you go. Escape ZZ is how you get out if you forget to do the -m flag. Git commit -m, and let's type added an image. We've added an image. Awesome, cool. Git push if you want to do the push to the server. Okay, now I'm going to do git checkout. Git checkout new feature. So there I'm on the new feature branch. I'm going to do git merge master. So this takes the copy of the takes all the changes on the master branch, and it basically brings them into this branch here. Now, cool. Look at image.png, right? I am now going to edit this file image.png. So here it goes. I'm going to write some stuff onto that image and draw some stuff on it. Save it here. Okay, I'm going to commit that change onto this branch. So it'll be git add dot git commit -m image. Okay, now I'm going to check it the master branch. Cool. Oh, what? That file should have been edited. Image.png, if I open that in MS Paint. There it is. Okay, so this is the version from the master branch. On the new thingy branch, there's an edited version, so I'm going to edit it here as well. So this is a case where like there's a binary file on two branches which have edits on them. And now Git is also going to give us a merge conflict with this, and I'll show you very quickly how to merge those. So now if I do git add dot here, and now I try and merge in the changes from that other branch. Automatic merge conflict. So the merge conflict is now in image.png. Because it's a binary file, Git has no idea which version of those files to keep. So how you resolve a merge conflict on a binary file, now this could be a scene file, this could be an MP3 file, it could be a WAV file, it could be any binary file which isn't like source code. You use this, git checkout, and then you use this extra flag --hours to basically say keep the one from the master branch, or --" theirs to say keep the one from the branch you're trying to merge in, which in our case is called new feature. Okay, so git --hours. The file is called image.png. That gets our version of it. There's the file there. You can also type git checkout --" theirs, and that will get the version from the other thing. So if I open up the image now in MS Paint, it's gotten the one from the branch. Alright, so that's how you resolve a merge conflict on a text file, in other words source code, and now you know how to resolve a merge conflict on a binary file. Again, you can do all of this from like the GitHub client or from Git Kraken, but this is basically what it's doing. And if you want to like really be a boss of Git, this is the way that like people who I guess like programmers typically use Git this way rather than use a GUI client. You could use a GUI client as well if it helps. For me, I use Visual Studio Code and I use the bash, and that kind of like gets me through. And hopefully you can see like there's not that much I have to learn. There's maybe like, I don't know, 10 or 15. There's git init, git remote, git add, git commit, git push, git pull, git branch, git merge, git log, git checkout. Did we say that one already? It's 10 commands basically. That's it. And then you're basically a Git boss. And we've done all of that in about 1 hour. And the other thing about Git is it's one of those things that like after a while, it's just like, oh yeah, exactly, Git init, blah, 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 blah. You just get really, really good at it after you've done like Git like this a few times. So I actually have a really cool lab that I can share with you guys in the second part of today's class where we can try this. So listen guys, I'm going to end the live stream here. Yeah, so listen, we'll rejoin on Teams. I'll share the link with you guys for the project fair, which you guys can join on Teams for the last half hour of this thing. Otherwise, I'll see you guys at 3 o'clock, and you know, I'll show you how to do this for a Unity project, and then you know we can basically work on the assignment. You can get your assignment set up in GitHub. Okay, everybody, see you over in Teams. Bye.